So in this series we discuss series and parallel circuits, and we have some examples of both of them, and we just discuss more of the principles. We also do some measurements. So again, here are the three resistors. You can look at the color codes to determine the resistances of these resistors, and you can record that in your document. We'll first look at series circuits. Again, you can see here the way the components are connected in a straight line, and when we measure them, we have two 10 ohm resistors. We have a resistance of 20 ohms. Again, here are three resistors connected in series using the breadboard. In this example here, they are connected and powered by a 5-volt source coming from this Arduino. And so here, I'm measuring the resistance. I'm measuring the total current that is flowing in the circuit. And so it's you can see from the screen 1.39 milliamps. Now I configure the meter to measure voltage V, and I make sure that the terminal is in the V port for voltage. And now I measure the total voltage coming in, followed by the voltage across each resistor. So across this one is 1.37, across this one is 3.23, and across this one we have 0.65. So we can see that these all add up to 5 volts, right? So in other words, we have a voltage drop. So from 5 we go to 3, from 3 we go to 0.6. So in other words, we just subtract the voltage across this one and across this one. What about parallel circuits? Again, in parallel circuits, all the components are connected together. You can see with this parallel circuit, both legs or leads of the resistors are connected together and to the source, and the resistance is not straightforward. This is what a parallel circuit looks like with the breadboard. Right, essentially with the breadboard, all those rows here are connected. So if we put them in the same row, they will be connected. And then we can measure the total parallel resistance, 277 ohms. If we remove one of the resistors, we have 0.679. So here we are measuring, when we power this circuit with 5 volts, we are measuring the voltage across each resistor, and the voltage across each resistor is about 5 volts because they're in series with the source. Now we configure the meter to measure current. So we set the terminal, and then we need to change the circuit. So we change the port from V ohm to the milliamp port. Okay, now we disconnect the circuit, and then we use the meter as a jumper to allow the current to flow through the meter. So here we're measuring the total current. It's about 17.89 milliamps. And to measure the current in each resistor, we disconnect them so they're no longer in parallel. So we separate all the resistors, and then we're going to measure the currents independently. Now we'll add up these currents, and we'll see that they will add up to about 17 milliamps. So we'll be measuring current in the first resistor, because we said in parallel circuits, each current draws its current independent of the others. So for the first resistor, the current is about 10.7 milliamps. For the second resistor, the current is about 2.33 milliamps. And for the third resistor, we have a current of